Thank you, Jerry. And once again, I'd like to thank Jerry and NewEra Software for sponsoring these crypto sessions on the V2R1 Exchange. As you may be aware, we started in January with a 12-month series of sessions on crypto topics. In January, we did an intro to crypto, and then in February and March, we covered the hardware technology that's available on System Z. The original plan was to do a two-part session on ICSF in April and May. However, due to some technical difficulties with the recording in April, and just because I tend to be naturally long-winded, that ICSF session is now going to be a three-part session going April through June. So before we get into the agenda, let me go to slide 2 and point out that this material is based on work that I've been doing for had been doing for the past 10 years with IBM. As many of you are probably aware, I left IBM in April of 2014, retired, and have set up my own business. Now, the technology is the technology, so these slides may look familiar because they're based on the crypto support that I've been providing for in the past at IBM. I'm going to slip to slide 3, and I want to acknowledge that a lot of this material is trademarked by IBM. It's similar to what I did at IBM. But now that I've left IBM, I can also cover some of the other products as well, and specifically toward the end of this session, I get a chance to talk about some of the SAF capabilities, and instead of just covering RACF, I'll cover ACF2 and Top Secret as well. And I want to thank Carla Flores from CA for helping me with some of those slides. On slide 4, the agenda, again, we're going to cover ICSF and cover it from a couple different aspects. In April and May, we're going to focus on ICSF from a systems programming perspective, specifically getting things up and running. To do that, we're going to talk about the key repositories and verification patterns because that's kind of important in ICSF being able to keep the master keys and your operational keys in sync, and we'll expand on that quite a bit today. Then we'll get into the actual steps that you must perform to get ICSF up and running. We'll talk about some of the options that you can specify and how they can impact operational procedures as well as performance. And then we'll turn to some other things that come along with ICSF. You do interface with ICSF via ISPF and TSO, so we'll talk about some of the capabilities there. We'll talk about some of the health checks that are available. They've been introduced over the last several versions of ICSF. And then we'll briefly look at the SMF data that is generated by ICSF. And then in June, we'll turn our attention more to the application side of ICSF. We'll talk about the keys that are available. We'll talk about something called control vectors, which are introduced by the IBM Common Cryptographic Architecture that we talked about in January. So we'll look at some of that. Then we'll look at the APIs, just kind of an overview of what's available and how they work. And then finally, we'll talk about securing resources within ICSF, things like securing keys as well as some security policies that you can implement. So let's go to slide 5 and get into a little bit of the meat of the presentation. ICSF is a software component that comes with z/OS. It provides the interface to the hardware. That is one of the primary things it's doing, is enabling the use of the hardware. Now, if you remember in February when we talked about the CP Assist for cryptographic function, or the CPAC-F hardware, we talked about the fact that it provides some native assembler instructions that you can invoke from your own assembler routines. Those work just like a move character instruction. The KM instruction will take data from storage location 1 and move it to storage location 2. But when it gets to storage location 2, it is in fact encrypted using the algorithm and the key material that you specified. So you can invoke those instructions directly without using ICSF. However, ICSF does provide APIs that can be used to invoke those instructions as well. Now, what that gives you is a little bit more portability. That is, in theory, if you write to the APIs, you can move that code from one machine to another, and ICSF should provide some of the capabilities there if maybe the hardware support is not available on a newer machine, or more likely, if you move it back level, maybe you take this code to your DR site where you're running a back level machine, then hopefully ICSF can provide some portability there and still provide the functionality. In addition, the Crypto Express card, the only way you can access the Crypto Express card is via the APIs. IBM does not externalize how you or a way to implement functionality on the crypto cards other than going through the APIs. So if you want to do secure key operations, you must use the APIs to access the cards. In addition, there are a number of other APIs that aren't specifically tied to hardware. Those APIs include things like query functions. So there's a query algorithm API. So you can find out what APIs or what algorithms are available in your environment. There's a hardware query, so you can see what devices are installed and look at what specifically is available on those devices. There's also a number of APIs for key definition and key management. So you can create there are APIs that will create key material that will go out to the hardware and create the key material, but there's additional APIs that once you have the key created, it will build the tokens, it will build the records, the key records that can be stored in the CKDS, PKDS, and TKDS. So those APIs aren't specifically tied to the hardware, but they do provide a valuable interface and the ability to create keys and manage keys. Now, as already hinted, you can manage your crypto environment from the ICSF panels that are accessed via TSO and ISPF. You can take devices online and offline, and we'll talk about those capabilities when we get a little bit farther along. As I mentioned in the January session, kind of an intro to crypto, one of the critical components of your crypto environment is the security and integrity of your key material. So ICSF provides a way to securely manage and keep your key material available, and with the integrity that you need to know that you've got the right key material available. So ICSF provides that interface for managing the master keys and keeping those key repositories in sync. And when we talk about the verification patterns a little bit more in a minute, you'll see that in a little bit more detail. And then finally, ICSF does provide a security environment, so you can protect your key material, you can protect the APIs, you can control who can execute which APIs. We'll see that there's also protection for the KGUP utility, the key generation utility program for generating and managing operational keys. And then, as we mentioned on the previous slide, there are policies that you can define, kind of more general security environments that you can enable, and we'll talk about those a lot more in June. Let's go to slide 6. This slide is a cut and paste from a tech doc that is available at the IBM Tech Docs website, www.ibm.com/support/techdocs. What it shows is the recent current versions of ICSF. That tech doc also has a history page, so it's got some of the older versions in there as well. Now, what this shows is the version of ICSF and how it was distributed. So if you installed a ZOS operating system, ICSF came with that operating system. And the version that came was the version that was then current when IBM packaged the operating system. So there at the top of the chart, you can see that if you ordered and installed ZOS 112, that came with HCR 7770. That was the current version when ZOS 112 came out in September of 2010. Similarly, ZOS 113 was shipped in September of 2011, and the current version of ICSF at that time was HCR 7780. So ICSF ships with ZOS. However, IBM may create newer versions of ICSF to correspond with probably hardware announcements. So HCR 7790 came out in September of 2011, just after ZOS 113 came out. It introduced support for coordinated KDS administration. We'll get into all of those a little bit later. ZOS 2.1 came out in September of 2013. It shipped with HCR 7780. Now, 7780 was originally available in September of 2012, and that corresponded with the announcement of the then new machine, the EC12, and the Crypto Express 4S cards. So what IBM did was, in that gap between ZOS 113 and ZOS 2.1, we announced new hardware, and there had to be a new version of ICSF that would support that hardware, and that was 7780. Once ZOS 2.1 shipped in September 2013, that was the version that shipped with it. Now, at the bottom of the page, HCR 7781, that came out and that provided some more support for the then new hardware, the BC12, and that hardware support was also retrofitted in what IBM calls General Availability 2 for the EC12. So 7781 is the most current version of ICSF. If you are in the process of installing ZOS 2.1, you haven't put it in production, I would encourage you to consider going ahead and downloading HCR 7781 from the ZOS Downloads website. And there's a reference to that in the at the back of this presentation. But by downloading that and installing it on top of your ZOS 2.1 system, you will be able to take advantage of the most current technology that's available today. Even if you aren't running an EC12 today, ZOS 2.1 will still run on older machines. And if you look at that rightmost column, the supported servers, HCR 7781 will run on Z890s and Z990s, very old machines. So ICSF is very upwards and downwards compatible. That is, you can run new versions of ICSF on old hardware. Now, that new version of ICSF might support some things that aren't supported in the hardware, so those functions won't be available, but in general, ICSF will run on that old hardware. Similarly, you can run an old version of ICSF. HCR 7770 is the oldest supported version of ICSF today. It will run on a ZEC12. Now, the EC12 provides some functionality that you can't access with HCR 7770, but again, 7770 ICSF will run on that new hardware. So by going to the most current version of ICSF, that provides you a lot of growth capability. So for example, if you're running on, let's say, a Z196 today, you go ahead and install 7781, everything will work just fine that you're doing today on that new version of ICSF. Plus, if, let's say, later this year you upgrade to an EC12 with Crypto Express 4S's, you will, as soon as you upgrade that hardware, be able to exploit that new technology. So that's why we recommend, if you're migrating to a new version of ZOS, it does make sense to consider installing the latest and greatest version of ICSF, just so you can grow as your hardware upgrades. Let's go to slide 7. Just kind of want to summarize some of the latest enhancements in ICSF and the capabilities there. Um, HCR 7790, if you remember from the previous page, that was kind of an intermediate version of ICSF. The big enhancement that came with 7790 was something called master key administration. And as far as I'm concerned, this is a very significant improvement in ICSF. What it gives you is easier management of your master keys, specifically for your triple DES and AES master keys and your CKDS. And you can now change master keys across a Plex much simpler than you could before. Prior to this support, if you wanted to change master keys, so let's suppose you're running in a Plex environment where you've got, say, 3 LPARs, and they're sharing the key stores. They're sharing your CKDS. To change the master key, you have to log on to each of the 3 LPARs, load your new key material into the new master key registers, and we'll cover master keys later in the year. But you have to log on to each system, load the new master key, then pick one system and implement the master key change and go through what's called a re-encipher, where you re-encipher your operational keys in the key store from underneath the old master key to the new master key. Once you do that on LPAR1, then you would have to log on to LPAR2 and tell him, all right, I've done the re-encipher, now let's go ahead and make the change. And then you would have to log on to System 3, LPAR3, and do the same thing. With master key administration, with this new master key administration support in 7790, now you can drive that change from one LPAR. You still have to log on to each LPAR 1, 2, and 3 and load the key material. If you remember when we talked about the Crypto Express cards, we talked about the fact that each LPAR is assigned a domain, and you have to log on to the LPAR to get that key material loaded in the correct domain. However, once you do that, now you can pick any of the members of the any members of the Plex, say LPAR2, and you can drive the master key change across all 3 LPARs from LPAR2. And what happens is you tell LPAR2, okay, we're going to do the master key change. He will notify LPAR1 and 3, hey, we're going to make this change. Don't allow any updates to the key store while this is going on. So he'll take care of the serialization for you. On LPAR2, you'll drive the re-encipher, so you'll read each key out of the current CKDS. You'll decrypt it from underneath the current master key, re-encrypt it under the new master key, and then write that newly encrypted key out to the new key store. Once that's done, ICSF will drive the master key change on LPAR2, and he'll actually move the current master key to the old master key register. He'll move the new master key into the current master key register. And then he'll tap LPAR1 and LPAR3 on the shoulder and say, hey, we're making a master key change. You need to make the change as well. Here's a pointer to the new CKDS that I just built for you. And now ICSF on LPAR1 and LPAR3 will take care of moving the current master key on that system to the old master key register, move the new master key into the current master key register, and then build a new key store data space from the newly encrypted CKDS. Once all 3 systems have made the change, he'll unlock the CKDS so that updates can be made. So you can drive that master key change across the entire Plex from one system. It is a much improved way to change and manage your master key material. HCR 77Able continued that master key administration update and provided the same support for the RSA and ECC master keys associated with the PKDS and for the new EP11 support, so the P11 master key and the TKDS can also be managed across the Plex from one system. In addition, HCR 7700 introduced a number of enhancements specific to the EC12 and the Crypto Express 4S card. So things like the new 24-byte DES master key support that is only implemented on the Crypto Express 4S. HCR 7700 is required if you want to move from a 16-byte DES master key to a 24-byte DES master key. Similarly, there's a new ciphertext translate that was reintroduced on the Crypto Express 4S cards. The only way to access that functionality is via HCR 7700. And then again, EP11 support is only available on the Crypto Express 4S. You must get the 7700 if you want to take advantage of that. There were also a number of enhancements to KGUP. KGUP is much more comprehensive, supports all operational keys now. There were a number of other enhancements in 7700, but I think those are the big ones worth noting. 7701, as I mentioned before, that came out to support the then new ZBC12 machines. With the BC12, there was some UDXs that have been integrated into ICSF. When we talked about the Crypto Express cards, we talked about the fact that those cards support a user-defined extension, basically giving you the ability to load your own application-specific code inside the tamper-resistant boundary of the Crypto Express Crypto Express cards. There are a number of UDXs that lots of customers use, and so those have been somewhat standardized and are now generally a part of ICSF. You no longer have to have a UDX. They've been integrated into ICSF. ZBC12 also introduced support for exporting triple DES keys using an AES key. That is a triple DES key can now be exported using a longer AES key, and that's to meet some of the cryptographic standards in terms of export functionality. That was introduced with the BC12. It was retrofitted to the EC12 as well. So if you're running GA2 of the EC12, you have that capability. And then finally, there were some Europay, MasterCard, Visa enhancements. New standards that have come out have been implemented in the hardware, and that support was implemented via 7701. There are some SAP enhancements. There's some new dynamic special secure mode support. We'll talk about special secure mode a little bit later on when we talk about some of the options available. And then the last big enhancement on 7701 is something called KDS record format and utilization stats. And the idea here is that IBM has realized that they have to do more in terms of helping you to manage keys. So they've introduced, or they are introducing, a new date last used and time last used field into the key token. So within the key token in the key store, in the CKDS, the PKDS, and the TKDS, they're adding some fields, specifically a date last used and a time last used field. So you can go back and check those records and see when a key was last used. Now, with 7701, you can't really, there aren't any utilities to exploit that yet. But by virtue of the fact, by migrating to 7701 now, you can start populating those fields. And presumably in later versions of ICSF or further down the road, there will be other utilities that can go in and look at that date and maybe make some decisions based on the date last used. So that theoretically could give you the ability to come back a year or 2 years from now and say, well, if a key hasn't been used in a year, can I delete it? Can I archive it? There's going to be some capabilities that will use this field, but you've got to get to HCR 7701 just to start populating that field and get ready for those new capabilities. Let's go to slide 8. Slide 8 kind of just describes ICSF and what it's providing for you. Again, it's the interface to the hardware. So over on the right, you can have your own local applications. You can have products like the encryption facility for ZOS or the data encryption tool for IMS and DB2, or even OEM products that call the APIs. You can also have components of ZOS like System SSL or PKI services that will take advantage of the hardware. Now, those can invoke the APIs. The work will be handed over to ICSF, and the first thing he's going to do is perform some SAF checks and make sure that the caller's authorized to use those APIs and maybe that key material. And then ICSF is going to be in charge of routing that request to the appropriate hardware. So if you code an API that uses the CPAC-F hardware, ICSF is going to turn around and invoke those KM or KIMD instructions, the encryption instructions, the cipher instructions, or the hashing instructions that will get performed on the CPAC-F hardware for you. Alternatively, if you code an API that requires the Crypto Express card, ICSF will route that work to the Crypto Express card. He will take care of the load balancing. He will handle figuring out which card is the best one to service that particular request. If you remember when we talked about the Crypto Express cards, we talked about the fact that there are multiple engines on the card. So there's DES encryption engines, there's AES encryption engines, there's a random number generator, there's RSA engines. ICSF can route multiple operations to the card. Each card can handle roughly about 8 different threads at a time. So ICSF will monitor how many threads are running on each card. If one card starts to get busy, ICSF will see if there's another card available and will start routing work to that second card. And when that card starts getting busy, it'll look for a third card. There's nothing you can do to control that routing. To manipulate how things are routed to various cards, but ICSF takes the responsibility for making sure that the performance is there and you're getting the best performance with the available resources. ICSF is also, as we've talked about before, responsible for managing the key stores. So there are APIs that will read and write records from the CKDS, the cryptographic key data set, where we store store symmetric keys. The PKDS, the public key data set, where we store public-private keys, whether they be RSA or ECC. And finally, the TKDS, where we write P11, EP11 objects. They're stored in the token key data set. When ICSF starts, it will read those key stores and build data spaces for each one. So we do that for performance reasons, so it can route work or so it can get the key material from out of a memory as opposed to having to do the I/O to the cards or to the data sets every time it needs it. Finally, there's also an ICSF options data set. That's where ICSF decides how the environment will be configured. We'll talk about what's some of the important parameters in that options data set, but those are read at startup time and used to establish the environment. We'll see in a minute that one of the options or the options parameters are pointers to the key stores so that ICSF knows which key stores it's supposed to use today or for this instantiation of ICSF. Finally, up in the upper right, again, there are ISPF panels that are provided for managing the crypto environment within ICSF. There's also support for the Trusted Key Entry Workstation. So the TKE can talk directly to ICSF and push data directly to ICSF and the Crypto Express cards. So ICSF is that component of ZOS that provides the interface to the crypto hardware. Let's go to slide 9. I'm going to talk a little bit more about the key repositories and the important role that ICSF plays in making sure that you have the right key material available. So again, there are three key repositories: the cryptographic key data set, the PKA key data set, and the token key data set. The CKDS is where we store symmetric keys, AES and DES, and more importantly, triple DES keys now. The PKDS is where ICSF goes when it needs a public-private key, whether that's an ECC, an elliptic curve key, cryptographic key, or a RSA public-private key pair. Now, in the PKDS, you might have a record that contains both the public and the private key if it's a key that you own, or it could be just a public key that's stored there. If you've stored the public key of your partner, you would not have access to their private key. They're going to use the private key, but you would store their public key in your PKDS. And then additionally, in the PKDS, we also store trusted pin blocks. Those are associated with ATM pin processing. Those are kept in the PKDS. And then finally, the token key data set is where we store cryptographic objects. So this might be key material, and it might be in a number of different formats, whether it's an AES, a symmetric AES or triple DES key, or a public-private key. Those are all stored in the TKDS. With the implementation of EP11 support on the Crypto Express 4S and with HCR 77able1, you can now store both clear keys and secure keys in the TKDS. Prior to that, the TKDS was a clear key only data set. It only contained clear key material. But now it can have a TKDS as well, and we'll see how ICSF keeps those keys secure on the next slide, slide 10. So one of the things that ICSF does or has to do is it has to make sure that when you store a key, a secure key that's encrypted under a master key, he has to be sure that when he wants to use that key a week from next Tuesday or a year from now, the appropriate master key is available. So think about that for a minute. If we create a secure key, maybe our secure key, the actual value is ABCD. When ICSF stores that secure key in the repository, it's going to store it encrypted under the master key. So if somebody can just dump the CKDS and look at the contents, they're not going to see the actual value of ABCD. They're going to see the value after it's been encrypted under the master key. To be able to recover it a year from now, that same master key has to be available. If you remember when we talked about the Crypto Express cards, we talked about the fact that those master keys are stored inside the secure tamper-resistant boundary of the card, and there's no way to extract them. But you probably need some way to track which master key is installed in the card, which is loaded in the card. So what happens is ICSF will generate a hash of the master key and use that to represent the master key. So when you load your master key, and let's specifically talk about the AES master key, when that master key is created, the hash is calculated, and in this case, the hash of the AES master key starts with Fox03 Charlie. So if we try and display the contents of the Crypto Express cards, the usage domain that's usage domain 1 in this case in the Crypto Express card, we don't see the actual master key. We see the Fox03 Charlie that represents it. When ICSF initializes its key store, it will store that hash value in a header record in the key store. So down at the bottom in the CKDS, you see that the Fox03 Charlie is stored in the CKDS as well. We do the same thing for the DES, triple DES master key. We do the same thing for the ECC and RSA master key and the P11 master key. Now, when ICSF starts and you point it to a CKDS, one of the things that it's going to do is it's going to go out to the Crypto Express card and calculate the hash value of the master key that's loaded in the Crypto Express card. It's going to compare that to the header record in the CKDS. And if those two values match, ICSF knows, I know I've got the correct master key that's associated with this CKDS. That means when somebody wants to use a secure data key out of the key store, it knows it can properly decrypt that and recover the original operational key. If for some reason those two values don't match, ICSF says, wait a minute, there's something wrong here. I know that I don't have the right master key. I can't use these secure keys in this key store. At that point, ICSF is going to give you some messages that say the master keys are correct. The only thing you can do at that point is fix the problem. That is, you can load a new master key into the Crypto Express card that does have the Fox03 Charlie that matches the key store. And at that point, ICSF will be happy and it'll let you use those operational keys. Or you can point to a different CKDS that does match what's inside the tamper-resistant boundary of the Crypto Express card. So this is an important capability that ICSF provides to be able to give you the confidence that you have the right master key value. Therefore, you will have the correct operational keys when you need to use them. So this is an important capability of ICSF to provide you the security and the confidence that you have the correct key material available when you need it. Let's go to slide 11. This is just a sample of the header record in the CKDS. So the first thing I want to point out is that all of the keys in the key stores, whether the CKDS, the PKDS, or the TKDS, whether it's the header record or the actual key tokens themselves, those are documented in the System Programmer's Guide. So if you have access to if you can read the key stores, the CKDS, PKDS, and TKDS, you can go look at individual records and see some information about the keys. This again is the header record, and it's specifically for the variable length CKDS but for the variable length CKDS. We're going to see in a minute that over time the layout of the key stores has changed, and we'll talk about it. This is specifically for the CKDS that was introduced with HCR 7780. Now down at offset 108, you see the DES master key verification pattern, and at offset 124, you see the AES master key verification pattern. So you see there that Fox03 Charlie that we saw on the previous slide. This is the header record that has those hashes stored in it. This is where ICSF will go at initialization time to make sure that things are in sync. Let's go to slide 12. I'm going to shift gears a little bit at this point and talk about the installation of ICSF. So if you just, there's two possibilities here. One, you might be a brand new customer that's just implementing crypto for the first time. So you're doing what's called a new install. You don't have any keys in your key store. You're going to set the environment up so that you can start putting keys in your key store. More likely, you're probably going to be upgrading an existing system. Maybe you're going to be installing a new version of ZOS that comes with a new version of ICSF, or maybe you're just upgrading the version of ICSF to get some new capabilities. In that case, your key stores are already going to exist, and we've got to preserve that going forward. The installation in the System Programmer's Guide is written a little bit more from the perspective of a new install, but as we go through these steps, we're going to consider both aspects. What do you have to do if this is a new install? What do you have to do if this is an upgrade and you've got to bring your existing key store forward? Now, a lot of times we get questions from customers. Somebody in the past implemented ICSF, created the environment, maybe loaded the first master key, probably using passphrase, but that person has long since retired, and we don't know what we have to preserve and what we've got to do to bring things forward. So the first thing you have to realize is, if you have key material in the key store, then you're probably going to need to bring that key material forward. So the first thing to check is, to look at the CKDS, the PKDS, and now the TKDS. Are there any records in the key store? If there's only one record in the key store, that says somebody set up the environment, but they never and they created that header record, that record that has the master key verification patterns in it, but they never added any more keys. So if you only have one record in the CKDS, that says I don't have anything important in here, I don't have any keys stored. You could create a brand new CKDS and just start from scratch. However, if there's more than one record in there, that says somebody created a key and stored it in the key repository. At that point, the question becomes, well, now, is there any data that's encrypted with those keys? Because if you don't preserve that key, if you don't bring that key forward, any data that was encrypted under it is effectively lost. That is, it's considered cryptographically erased. If the data is encrypted, but the key's not available, you cannot recover the data. So my recommendation is, if you have more than one key in your key store, you probably need to bring that forward unless you know absolutely 100% that key was not used to protect any data, or if it is, we don't need to keep that data around. That's the only situation where you could theoretically start over and create a new CKDS and PKDS from scratch. The other consideration is, again, do you know what the master key material is? Do you know what the master keys are? If master keys have been loaded and you don't know how they were loaded, you don't know what the passphrase was, or you don't know what the key parts are, that's not a disaster. You can recover from that environment. The Crypto Express hardware still has that master key loaded. It knows what the master keys are, even if you don't. You can at that point go through a master key change and get to an environment where you know what the master keys are, what's actually loaded. Again, we'll talk about a master key change in July, I think, or actually probably in August. We'll go through the process of loading master keys. So don't despair if you don't know what your master keys are. But if you don't know what they are, as soon as possible, you want to go through this master key change process and get to a point where you know what the master keys are. That way you can recover if you have a hardware failure. Say one of the Crypto Express cards fails, you can reload that master key that you now know and get that into the hardware and move forward. So again, we're going to look at this from both the perspective of a new install or upgrading ICSF as we go through the steps. Let's go to slide 13. Again, the first step is installing the new version of ICSF. Again, you may be installing ZOS 2.1, in which case you're going to get HCR 77ABLE0. That may be sufficient for your environment. I would encourage you to consider installing HCR 77ABLE1 on top of that, just so you have some growth capability as you upgrade the hardware, as we've talked about before. It's not required, it's just something to consider. If you want to install that latest version, there's the link to the web download site. You basically, it's just like anything else you do today in terms of installation. You can download the FMIT in this case, and then go through the SMP process of applying and accepting that FMIT on top of your new ZOS 2.1 system. Of course, you want to check the PSP buckets just like you would for any other product. See if there's any late breaking news, any hyperfixes that need to be installed. The other thing you need to think about are toleration and coexistence APARs. Again, especially in a shared environment where you might be sharing your key store between multiple systems, when you upgrade a version of ICSF, you're going to likely either introduce new fields in the key store or new records in the key store. For example, with HCR 7780, we introduced a new HMAC type key, a hash message authentication code key. If you upgrade ICSF and the new version of ICSF starts putting these new records into the key store or new fields into a record in the key store, an older version of ICSF is not going to know about those new records and new fields. So there will typically be toleration or coexistence APARs that need to go on the old versions of ICSF to tell those old versions, hey, you're going to see this new record or this new field in a record. Don't choke on it. Don't throw up when you see it. You can't take advantage of it. The old version of ICSF doesn't have the support maybe to take advantage of the date last used field. But at least when it sees it, it won't ab in because it hasn't seen that field or that structure before. So it's important to look for toleration and coexistence APARs as you upgrade your ICSF, especially when you're running in a shared environment. Let's go to slide 14. The next step in terms of installing ICSF are going to be updates or changes to ParmLib. Now, these are fairly stable. These don't change very often. Your APF list has not changed for a number of versions of ICSF. And as you can imagine, ICSF does some pretty powerful things, so it has to run an APF authorization. It needs to be in linked lists so it can find the libraries it needs. The IKJ TSO ParmLib describes some of the programs and commands that have to run in an authorized state under TSO. Again, those have not changed. The last one there, the couple XX member, that's actually new with the EP11 support that was introduced with HCR 77ABLE0. There is some information that can be stored in the coupling data sets that ICSF can take advantage of, specifically with the EP11 support. So if you want to take advantage of that, you're going to have to update the couple XX member. So whether you're installing new or upgrading from a version of ICSF, you need to check the ParmLibs, see if there's anything new that needs to be added. For the most part, these are going to be relatively stable. Let's go to slide 15. The next step is to define the key stores. Now, the CKDS and the PKDS are required data sets. They must be defined. We're going to see a little bit later. They must be pointed to in the options data set, but ICSF expects to have access to those data sets. They're just vanilla VSAM data sets. There's nothing special about them. ICSF will take care of encrypting specific fields within the records, specifically the key material itself. But these are just generic vanilla VSAM data sets, which means you can use your existing utilities to manage them. You use IDCAMs to define them. When you want to create backups, you can use DFSMS, DSS, or FDR, or whatever will work. You can create the backups, the archives, as well as the backups that you use maybe at a DR site. If you're doing a first-time install, you will simply define these data sets and point to them when ICSF starts the first time. There will be nothing in them. When you load the master key, and we'll talk about this a little bit later on, it will take care of initializing and creating those header records that have to exist for ICSF moving forward. If you're migrating from an old version of ICSF to a new one, you're just going to point to the existing CKDS and PKDS. Now, again, there may be some APARs, there may be some conversion you have to go through, and we'll talk a little bit more about that in a minute. It really depends on what version you're coming from. If you're coming from a very old version to a much more current version, there's more likely to be some conversion utilities that you have to run. So you'll have to look into that as well. And then finally, you want to SAF protect these libraries. If you create clear keys in your key store, that key material is in the clear. If you create a clear key with a value of ABCD and somebody can dump use ITCAMs and print the VSAM data set, they could see the key material ABCD in that data set. So you want to SAF protect them. The only address space that must have access to these key stores is the ICSF address space itself. So you probably want to set them up with a UAC of none. Now, I can see having fire call IDs and all that maybe have the ability to read the key stores. There may be instances where you have to look, well, what is the key? Let's go look at that record, see that, is it an AS key or is it a triple DES key? So you can tell what's going on. But in general, no one except ICSF should have access to these key stores. And if you do create fire call IDs, then you want to do the appropriate logging and make sure that do they have a legitimate need? Is there truly a fire going on that they need to access the key stores and look at the key material that's in there? On slide 16, the format of the key stores has changed over time. Going way back prior to HCR 7780, the cryptographic key data set was a fixed length data set, record size 252 by 252. With HCR 7780, we introduced a new type of key called an HMAC key. Now, the standards for HMAC keys say that they can be variable length keys. So with HCR 7780, we introduced support for a variable length CKDS so we could store these keys. And now with HCR 7781, with this new KDS record format and introducing those date last used and time last used fields, we've had to increase the length of the record so we can support those fields as well. Now, the HCR 7781 can still use a record of fixed length CKDS, a 252 by 252 key store. It'll still work. Or it can use the HCR 7780 key store that's record size 332 by 1024. It will still process those old keys. However, if you're running a fixed length CKDS, you can't store any HMAC keys. And if you're running either an old fixed length or the 332 by 1024, you're not going to be able to update that date last used and timestamp last used field. So if you want full capability, you are going to need to migrate the CKDS to this 372 by 2048. But as I mentioned before, ICSF is very upwards and downwards compatible. He can still run with those older key stores. Similarly, the PKDS prior to HCR 7750, we supported 512 and 1024 byte RSA keys. But with HCR 7750, we introduced support for 4096-bit RSA keys. We had to increase the size of the PKDS to handle those larger variable length keys. So it went to 350 by 3800. And now again with HCR 7781, the PKDS can also have this KDSR format and keep track of date and time last used. But to do that, we had to increase the variables, the length of the record from 350 to 800. Just like with the CKDS, the latest version of HCR 7781 can handle those older format key stores. But you are limited if you do. So there might be a conversion process that you want to go through to get to the record size 800, 3800, and being able to start keeping track of the date and timestamp last used. On slide 17, we talk about the TKDS. Now, the TKDS is optional from the perspective that if you don't want to use PKCS 11, if you're not doing any PKCS 11 APIs, you don't have to have a TKDS. You do have to have the TKDS if you want to store PKCS 11, EP11 objects for posterity. If you want to keep them in a key store, then the TKDS then at that point becomes required. Just like with the CKDS and the PKDS, if you're doing a new install, the TKDS will be empty when you first set up the environment. When you actually load the EP11 master key into the hardware, that's the point where that TKDS will get initialized, that header record will be created so ICSF can keep things in sync. If you're migrating forward, and so if you were running say HCR 7790 that supported clear keys in the TKDS, you can bring that forward with HCR 7781 and continue to use that. And you can now start, once you get your EP11 master key loaded, you can start storing secure EP11 key or objects in the TKDS. Again, you also want to protect this data set as well. Not just anybody should be able to read the TKDS, because again, if you have keys in the clear stored in the TKDS, anybody that can read it can see that key material. And then let's go to slide 18, which is the last slide we're going to cover today. The next step in the ICSF installation is creating the ICSF started task. Now, as you can see there, the started task is very simple. 3 statements. You've got your proc statement, you've got your exec statement, which points to CSF init as the initialization program. Prior to HCR 7770, ICSF actually pointed to a program called CSF main. So if you're running an old version of ICSF prior to 7770 and you're going to upgrade to 7770 or later, your started task is going to have to change. Now, what was going on here was the old version, the CSF main, it really didn't use standard ZOS protocols to do things it needed to do. With CSF init, there's now an entry in the program properties table. That's where it gets at the appropriate authorities that it needs. CSF main did some tricks and manipulated control blocks under the covers to get the security environment it needed. And with 7770, IBM decided, we really ought to use our own conventions and do things the right way as opposed to manipulating control blocks under the covers. So just be aware that if you're migrating from an old version of ICSF, you're going to have to change your started task to point to this new member. That PPT entry is created as part of the ICSF installation. And then the third statement here is the CSF PARM dataset. That is the pointer to the options dataset. We're going to see next month that the options dataset describes the environment that ICSF is going to be running under. So you've got to tell it which options dataset it's going to be using today. And we'll cover those options a lot more next month. Be aware that if you're doing a first-time install, you're probably going to have to update your security environment, add this started task to the started task table so that it gets the appropriate security environment as well. If you're upgrading ICSF from one version to another, then you've already done that, and you're probably not going to need to make any changes there. So with that, we're going to wrap things up for today. Next month, we will pick up with step 5 in the installation process, which is the options and some of the options that are available to you. So with that, I'm going to stop talking and turn things back over to Jerry and let him open the session up for questions. Thanks.